Assalamu alaikum wa rahmatullah. This is our project. We are Team Bytemasters, and this is our SAP 1 project. This is an accumulation of all the phases, and we have connected all the submodules together to form the full SAP 1, as we see here. For the submodules, we start with the clock pulse generator. This is our clock pulse generator with the manual triggers. We have the auto manual switch, which we can toggle between auto and manual mode. Then we have the clock, which is showing here, and a halt switch. Then we have the reset switch for the program counter. And then we move on to the program counter, which shows an output here. Moving on, we have the bus bar outputs. We have the 8 bus lines here. From the input side and from the output side, this is the calculation side, the accumulator, ALU, and the B register. The accumulator stores the data. But before that, we have the MAR, which takes the output from the program counter, and then it takes that input IO, I1, I2, I3, and it sends it to the address selector. From the address selector, we have two choices. We have either the manual inputs that we can put in here manually, and we have the inputs from the bus lines. So we can select for each, we can select a single one of the addresses and we can send it to the RAM. We send it to the RAM, which has stored data, which has 8 bits of stored data. We have 5 instructions and 3 data for calculation. We, in the cycles, we send these data, and through these instructions, we calculate what we need. The output from the RAM, it travels through the bus lines, and by the combination of the instruction register and the controller sequencer, which give orders as to where the data goes. It goes to the accumulator, it goes to the accumulator, and it goes to the B register. These two store the data for calculation in the ALU. In the ALU, we can have both the summation of two 8-bit data, binary data, and the subtraction of two binary data, along with a minus indicator and a natural subtraction output. And lastly, we have the output register, which shows the output by two 7-segment BCD displays, as well as we have 8 logic probes to show the output. Now, when we give the instructions to the SAP1, we have we can have 5 instructions for the completion of one addition cycle and another subtraction cycle. We found this from the video of Nadim sir, which explained these cycles. We will try to test our SAP1 project based on these things. So in here, we can have the addresses, the 5 addresses for the 5 instructions that we are sending. LDA9H, which would be to load the accumulator, add AH, which would be to add the data here, AH, which is the 10th address, which has a data of 2. Then it would be subtraction of BH, which would be subtraction of the BHS address of the data, and then we have output, and then we have out. Of these addresses and these programs, these 8-bit binary are divided into two nibbles, an upper nibble and a lower nibble. Of the upper nibble, it goes to the controller sequencer for different types of outputs, and the lower nibble, it goes to the bus. The lower nibble goes to the bus, and through this, it goes to the MAR. It goes to the MAR through the address selector and then to the RAM to load the data that we need, to load these data, that we need for further calculation. We will try an example program. We will try an example program now. We will follow the example program that was provided by Nadim sir in his video. To test our SAP1 project, we will run the simulation and we can see the clock pulse that is already running. We can see the outputs that are coming out due to it running, it being in run mode, we will turn that off and we will have program mode here. So in program mode, we'll program the values that we need in the RAM. For that, let's reset it first, reset the cycle first, and then we shall input the numbers that we need. Okay, now inputting these numbers, we will add these addresses to our RAM and use the read write button to set these values into our memory. So for address 0000, we have 0000 and 1001. So 0000, 1001, we'll write that. And then we have 1, we will use 0001, so that will be this, and 1010, so that will be this. Writing that. Then we have 0010, which should be this, and then 0010, and then 1011, which should be this. Then we have 0011, 0011, and then we have 0011, and then 0000, which is the out, and then we have 0100, this, and we have 1111, which is this. So we have all the values that we need for the example program set in the, we have all the instructions that we need in the example program set in the memory, and we will store the data that we need or the higher memory. So we have address of 1001, 0000, 0101. Then we have 1010, and we have this 1011. We have 11. So now we have all the data that we need. So now we can just reset all these and we can just run our program here. According to Nadeem Sir's example program, we should have an output of 4. It should show an output of 4. We have an output of 4 here. After this, this is the addition where we add 5 and we subtract 2, and then we have 5, we add 3, and then we subtract 2. Here we can have this 5, we add 2, sorry, we have 5, we add 2, so which is 7, and then subtract 3, which we get 4. We get the 4 output as here. To test our additional feature for this SAP project, we have introduced the summation of multiple numbers in our SAP project. So to find out the summation of multiple numbers, we take values. So from Nadim sir's video, we can use these 3 numbers and we can just exchange the sub instruction for an add instruction. So add BH. So that would be 5 plus 2 plus 3, which would amount to a number of 10. So for 10, we at first to prog mode and then reset it, and then we just try to run the values here. So address 0000, we have a prog of 1001. So like that. For 1, we have 1.010, and then we have 10, and then 011. So that'll be sub. So we need an add here. So for that, you need this 1011, and then we have 11. So it will be this, and 0000. We write, and then we have 10. If this, so that we have this. So right, and then we should set these values set these values. So 1, 0, 0, 1. So 0, 0, 0, 0, and then we have 1, 0, 1. And after that, we have 1, 0, 1, 0. So for that, we have 1, 0. So this, and then 1, 0, 1, 1. For that, we have 1, 1. So we take these values and just run. We reset it, and then we just run the program. We should get an output of A, which is hexadecimal for the number 10.